Hi everyone. This lesson is on using factoring to change from standard form to intercept form. So it's a continuation of what we did earlier. Our learning goals are to learn to use factoring to change a parabola from standard form, which is y equals ax squared plus bx plus c, to intercept form, so that we can tell what the x-intercepts are and the step number, and then from that we can find the vertex. And the second one, we're consolidating how to graph a parabola in intercept form by calculating its vertex and applying the step pattern. So example 1, we're going to rewrite each parabola in intercept form, determine the vertex of the parabola, make a sketch of the parabola, and then write it in vertex form. Okay? So the first thing we do is we want to identify the type of factoring that would be involved on the right-hand side. Okay, so remember back to our factoring flowchart, we would check for common factors first. There isn't one. Count the number of terms, 3 terms, and a simple trinomial has a 1 in front of the x squared, so we could consider this a simple trinomial, which would mean we were looking for 2 numbers that multiply to positive 36 but add to negative 12. And the only way to multiply to a positive and add to a negative is if both numbers are negative. So we can try negative 1 and negative 36. No, they add up to negative 37. Negative 2 and negative 18, they add up to negative 20. Negative 3 and negative 12 add up to negative 15. Negative 4 and negative 9 add up to negative 13. 5 doesn't go in. Negative 6 and negative 6 is our pair. Don't forget the y equals, because we're dealing with a parabola. So if we factor this, or rewrite it in factored form, it would be y equals x minus 6 times x minus 6. Which means it actually was a perfect square trinomial, which is fine, because we still factored it correctly. And we know from even the standard form our a value is a 1, so we know that our step pattern is going to be up 1, 3, and 5. And we recall that this is intercept form up here, so there's a minus in the formula, so it's x minus and then the x-intercept. So x minus 6 means that r1 is 6 and r2 is 6. So both intercepts are the same. They're both 6. 1, 2, 3, 4, 5, 6, which means that the vertex is 6. Okay? The only way that both x-intercepts can be the same is if the x-intercept is right on the vertex, and we also know the step number is up 1, 3, 5. So we can apply that and draw our parabola, noting our vertex was at 6, 0, that's our h and k, and we also know a is 1. So to write it in vertex form, we're going to substitute into the general formula for vertex form. So we would replace a with 1, which we don't need, it's understood to be there. X minus 6 squared, don't forget the squared, that's a common mistake. And then we could put plus 0, but we don't need to. And there would be the equation in vertex form. B, y equals negative 2x squared minus 20x minus 50. So we want to put it first into intercept form. So, and that's by factoring. So we're going to check for common factors first. And we can see that in this case there's a leading negative. So we're for sure going to have a negative as part of our common factor. But 2 goes into 20 and 50, so negative 2 is going to be our common factor. And notice that there is not an x in all 3 terms, so it's not part of our common factor. So if we mentally divide each term, so if there's 3 terms, when you common factor there should be 3 terms in the bracket as well. Mentally divide each term by negative 2 and you'll get x squared plus 10x plus 25. And if you wanted to check, you could always expand to see if you got back what you started from. So now if we follow our flowchart, it says to count the number of terms inside the brackets, and there's 3 terms inside the brackets. So it's asking, is it a simple trinomial? Again, it looks like a simple trinomial, but it's not a complex trinomial. Is it a perfect square trinomial? It could be a perfect square trinomial because the first term is a perfect square and so is the last term. So we could say it's a perfect square trinomial here. We need our -2 out front still. If it's a perfect square trinomial, then the square root of x squared goes here, the square root of 25 goes here, and the sign from the middle term goes here. And then our check would be that the first term times the second term times 2 should give you that middle term 10x, and it does. So it was a perfect square trinomial. If we hadn't noticed that and done a simple trinomial inside, we would have got x plus 5 times x plus 5. Much like up here, we got x minus 6 times x minus 6 by treating it as a simple trinomial. In either case, we still want to exaggerate it so it looks like intercept form. So we want to write this binomial out twice. And then that shows us that R1 is -5, because remember, there's a minus in the formula for intercept form. So in order to have x plus 5, you would have had to have x minus -5 in order to see an x plus 5 in the bracket. And that's why R1 is -5, which is also R2. They're both -5. So that again means that the vertex is right on the x-axis. The only way that both intercepts are the same for a parabola. So think about all the parabolas. Most of them have 2 x-intercepts. Some of them have none. Like if there was one up here, it would have no x-intercepts. Okay. Same thing if there was one down here, it would have no x-intercepts. But the only way it can have one is if its vertex is right on the x-axis. So now our step number comes into play. It's -2, which means it's going to be down because of the negative, 2, 6, and 10. And we can't fit the 10 on, but that's what our parabola would look like. And we have to write it in vertex form. So we know that A is -2, and we know our vertex is at -5 and 0, which is our H and our K. We can substitute it into the general form or vertex form, which is going to give us y equals -2, x minus -5 squared, but minus -5 is the same as plus 5 squared, and then plus 0, but you don't really need that, and that's your vertex form. Okay? Next question, y equals 2x squared minus 13x plus 15. So following our factoring flowchart, we would check for common factors first. So we would hope that 2 is in common with 13 and 15, but it's not, okay? So then if we don't have a common factor, then we count the number of terms, and there's 3. Is it a simple trinomial? No, because there's a 2 in front of the x squared. So it's a complex trinomial. So for a complex trinomial, to factor it, you have to use decomposition. And the first step of decomposition is to multiply 2x squared by 15, which gives you 30x squared. And then you need to come up with 2 terms that multiply to positive 30x squared, but add to negative 13x. So your 2 terms will both have to be negative to multiply to a positive. So we can try negative 1x and negative 30x, but that adds up to negative 31x, so that's not it. Negative 2x and negative 15x adds up to negative 17x, also not it. Negative 3x and negative 10x does add up to negative 13x. So now we're going to, don't forget the y equals, we're going to copy out our first term, 2x squared, and ask what has more in common with 2x squared. I would say negative 10x does. because 2 goes into 10. And then minus 3x plus 15. So again, that's our step where we just take negative 13x up and decompose it into negative 10x minus 3x so that we can now factor by grouping. So we look at what's in common with just the first two terms, and it's 2x. If you common factor 2x out of the first two terms, you'll get x, just x, minus 5. Sign that comes next goes next. And then what's in common with 3x and 15 is 3. So negative 3 is your common factor. Negative 3x divided by negative 3 is positive x. Positive 15 divided by negative 3 is negative 5. If you remember back, when you do everything correctly with complex trinomial decomposition, the binomials end up being common. So they form one of your factors, and the leftovers go into the other bracket. So this is called factored form, but it's not intercept form. So intercept form again looks like this. Y equals A, the step number is right out front, x minus R1, x minus R2. Okay, and we know our step number is 2, and we know that right now it's not out front. So the steps we take to change from factored form to intercept form, first I'm going to put the factor that contains the step number 2 in front, since it doesn't matter what order my factors are in. Then I'm going to force the 2, I'm going to common factor it out of this bracket. And again, we did something like this earlier, but I'm just going to show it on a blank piece of paper and then we'll transfer it. So if I force 2 to get factored out of 2x minus 3, 2x divided by 2 is x. 3 divided by 2 is 1.5. We don't normally do that because we don't want to factor and get a decimal answer, but we are forced to an intercept form so that we can know what the x-intercepts are. So that's how we change from factored form to intercept form. So we're going to apply that now. So I'm going to force the 2 step number out of this factor here. And then if I common factor 2 out of 2x minus 3, I get x minus 1.5. And then I still have the factor x minus 5. Stays the same. So now it is matching up to this form up here, intercept form. So by looking at this, I can see that the x-intercept, one of them is at 1.5 and one of them is at positive 5. So I would go ahead and mark those on my graph. 1.5 being here and 5 being over here. And then I would use my formula to find h and k. H is R1 plus R2 over 2. So 1.5 plus 5 divided by 2, which is 6.5 divided by 2, which is 3.25. So that's the h coordinate of my vertex. To get the k coordinate, I'm going to use this equation. I'm going to replace y with my k value, k, and then I'm going to replace each x here with 3.25. So then I'm going to get my calculator. 3.25 minus 1.5 is 1.75. And 3.25 minus 5 is negative 1.75. So then I'm going to multiply these three numbers together. 2 times 1.75 times negative 1.75 is negative 6.125. So that means my vertex is at 3.25 or 3 1/4 and negative 6.125. So that's a tricky vertex, but let's do our best. So here's 3. So 1, 2, 3 1/4 is just 1/4 of the way into this square. And then we're going to go down to 6.125. So 1, 2, 3, 4, 5, 6, and just a little bit below 6 would be 6.125. So there's my vertex. And now my step number is a 2, which means up 2, 6, and 10. We'll do our best here, and it should look like we would go through our intercepts, maybe not land on them, but go through them when drawing a smooth curve. So this is a quarter of the way into this square. So if I go over 1, I'm a quarter of the way into this square, and I'm going to go up 2. And then same thing here, if I go in the negative direction, I'd be a quarter of the way into the, so 2 1/4-ish, and then up 1, 2 here. Now I'm going to go over 1, so I'm a quarter of the way into this square, and up 1, 2, 3, 4, 5, 6. So you can see that it looks like I would be going through my intercepts. And then I would try going over 1 and up 1, 2, 3, 4, 5, 6, 7, 8, 9, and you can tell that it's going to be a bit up here. So I try drawing in a smooth curve. And then we've drawn our parabola. So this is H, and this is K, and we know A is 2. So we could write out our general formula for vertex form, and then substitute in our A value, which is 2, X minus our H 3.25 squared, and then our K is minus 6.125. Again, with this one, it's important to notice the difference between factored form and intercept form, and how we had to force the step number. We had to common factor it out in order to put it into intercept form. Okay, D. So again, we would check for common factors first. And there's a negative, but 2 doesn't go into 17, so it's just -1 is our common factor. Okay, so you could just write negative, or you can put the 1 there if you want to. And you're going to get 2x squared plus 15x plus 30. Okay, and you can see that if you were to multiply, distribute the negative through all 3, you'd get back to, oh, sorry, that should have been 17. You would get back to what we had in the first line. So there's our common factor. It was only -1. Now we're going to count the terms inside the bracket. There's 3 terms inside the bracket, so it's going to be a type of trinomial. It's not a simple trinomial because there's a 2 in front of the x squared, so it's a complex trinomial. So again, that means within this bracket we're going to have to start doing decomposition, which takes 3 steps. So 2x squared times 30 is 60x squared, and we want to add to 17x. So both of our terms will be positive. And I'm not going to write them, I know 1 and 60 is not going to work, that's 61, 2 and 30 is too big. I could start with 3 and 20, 3x and 20x, multiply to 60x squared but add to 23, 4x and 15x add up to 19x, 5x and 12x would be my pair that add to 17x. So I'm going to put my 2x squared down, and then I'm going to look what has more in common with 2x squared. I'm going to say 12x, because 2 goes into 12, and then plus 5x plus 30. So I'm still going to keep my negative out front, and then I'm going to start getting some nested brackets in here because I'm looking at factoring by grouping now. So just what's in common with those first 2 terms inside the bracket would be 2x. And then if I common factor 2x out of the first 2 terms, I'm going to get x plus 6. Close my bracket. Sign that comes next goes next. What's in common with the last 2 terms is 5, because 5 goes into 30. There's not an x in both of them. Positive 5x divided by positive 5 is x. Positive 30 divided by positive 5 is positive 6. So then within the brackets here, I've got this binomial common factor. So it's my binomial common factor. And the leftovers, 2x plus 5, form the other bracket. So this is considered factored form here. But again, we're going for intercept form. So we need the a to be out front, and right now part of it's out front, the negative sign, but the 2 is still in one of the factors. So I'm going to rearrange it so that the 2x plus 5 factor comes first and the x plus 6 factor comes second. And then I'm going to force the 2 out. So if I force the 2 out, I'm thinking again, if I force the 2 out by common factoring, I'm going to get 2 times x plus 5 divided by 2 is 2.5. Okay, so the negative sign is just out front here. Okay, so kind of that's there, but right now I'm focusing on factoring the 2 out of the 2x plus 5. So here's my 2. 2x divided by 2 is x. 5 divided by 2 is 2.5. And then the negative 1 is multiplying the 2 to give me negative 2. And then I have my x plus 6. So now it's an intercept form. So now I can compare it and see that for there to be a plus sign, it would have had to be x minus negative 2.5 in order to see that as a x plus 2.5. So I can see that one of my x-intercepts is negative 2.5 and the other one is negative 6. So I would go ahead and mark those on my grid. Negative 1, 2.5, 3, 4, 5, 6. So there's my 2 x-intercepts. And then I can calculate h using the formula r1 plus r2 divided by 2. Negative 2.5 plus negative 6 divided by 2 is negative 8.5 divided by 2, which is negative 4.25. And then to get my k value, I'm going to substitute into the intercept form. I'm going to replace y with k and each x with negative 4.25. Then I'm going to calculate each of those. So negative 4.25 plus 2.5 is negative 1.75. And negative 4.25 plus 6 is 1.75. Negative 2 times negative 1.75 times 1.75 is 6.125. So this time our vertex is at negative 4.25, negative 4 1/4, and 6.125. So let's plot that on our graph the best we can. So negative 1, 2, 3, 4 1/4, and then up 1, 2, 3, 4, 5, 6 and a bit, 6 and an 1/8 actually, but on these grid squares, just above 6 is good. And our step number is negative 2. So A is negative 2, which means down 2, 6, and 10. So we're going to use the same approach we did last time. So I'm going to move over 1, which would be 1/4 of the way into this square, and down 1, 2, just above there. And then over 1, down 2. And then I'm going to go over 1 and down 1, 2, 3, 4, 5, 6. and over 1 down 1, 2, 3, 4, 5, 6. And then I would go over 1 down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it doesn't fit on the graph, but we can draw it in with a smooth curve. Best you can, arrows on the ends. Okay, and now we want to put it into vertex form. So our general form, and then we're going to replace a with -2, x minus -4.25 squared, minus negative becomes plus 6.125. And there would be our vertex form. y equals -1/2 x squared plus 2. So we want to put it into intercept form. So I'm going to check for common factors first. The negative is, we always want to factor the negative out if there's a leading negative. And also if there's a half, you can always factor a half out. And we'll see why in a second. So -1/2 x squared divided by -1/2 is x squared. But let's think about 2 divided by -1/2. Okay? Well, first of all, if you just ignore the negative for a second, 2 divided by 1/2, how many halves go into 2? It should be 4. But we could also use the rule that when you're dividing by a fraction, you multiply by the reciprocal. So if we're dividing by -1/2, we'd be multiplying by -2/1. Which would give us, this is a times sign, so I should actually use brackets so it doesn't look like an X there. We could make this 2 out of 1, so we get -4 out of 1, which is -4. So we end up getting x squared minus 4. When we common factor the -1/2 out. And then look inside the brackets and count the terms. There's 2, so if there's 2 terms inside the brackets, if it were to be factored, it would be a difference of squares. And it turns out that it is a difference of squares. So this is going to factor to give us x plus 2 times x minus 2. Square root of x squared is x, square root of 4 is 2, and they have opposite signs. So now it's in intercept form. Remember intercept form. So because we see a plus 2 here, R1 must be -2 and R2 +2. So we can put those on our x-axis. We can find h by adding our x-intercepts together and dividing by 2. And that's going to end up giving us h equal to 0, which makes sense because 0 is halfway between -2 and +2. And our k value is going to be -1/2 times 0 plus 2 times 0 minus 2. And that's going to be +2. So our vertex is going to be at 0, 2. And then our step number, A, is -1/2, which means down 0.5, 1.5, 2.5, which makes sense with where our intercepts and vertex is. So over 1 down 1/2, over 1 down 1.5, we land right on our intercept, over 1 down 2.5, over 1 down 1, 2, 3.5, and 4.5 doesn't quite fit, but we can draw in our parabola with a smooth curve. And then we want to write it in vertex form. So we know our A is -1/2, X minus, or h is 0, 0 squared plus 2. Or you don't need the minus 0. If you don't want it, you can just write x minus 0 is actually just x squared plus 2. It's our vertex form. Okay, in our last example, so common factors first, but if there's a leading negative, we always treat that as a common factor. And I would hope 2 goes into all of them, but it doesn't. So I'm just going to factor the negative out for now. So each term will be opposite when you factor a negative out. And you can imagine if you multiplied this negative through, you would get back your original. Now you count the terms inside the brackets. There's 3 terms. It's not a simple trinomial because there's a 2 in front of the x squared, so it's a complex trinomial, which means we have to use decomposition. So 2x squared times negative 2 is negative 4x squared. And we need 2 terms that multiply to negative 4x squared and add to positive 3. So the bigger one has to be positive. So we could have negative 1x and positive 4x. That multiplies to negative 4x squared and also adds to 3x. So that's going to be the correct ones to use. So keep your negative in your bracket. I'm going to say 4x has more in common with 2x squared than minus 1x minus 2. Here's where we get our nested brackets, because we're going to, within this bracket, factor by grouping. So in common with the first 2 terms would be 2x. And then sign that goes next comes next. In common with the second 2 terms is just 1. Negative 1x divided by negative 1 is x. Negative 2 divided by negative 1 is positive 2. Then we have our common binomial. So I'm going to bring that out, and then the leftovers form the other brackets. And now we've put it in factored form. But what we really want to do is put it in intercept form. So I'm going to bring the 2x minus 1 factor and put it first, because we know we want to end up with an a value of negative 2. We've got the negative sign out front already, but we don't have the 2, so we have to force it out of the factor that's containing it right now. So that would give me x minus 0.5, because 1 divided by 2 is 0.5. So now we've put it in intercept form. So now we can see from this factor that R1 is at 0.5, and from this factor, R2 is at negative 2. So we can mark those on our x-axis at positive 0.5 and at negative 2. And then we can find h by adding our x-intercepts together and dividing by 2. So 0.5 plus negative 2 divided by 2 is negative 0.75. And then we can sub into our intercept form to find our k. So that's going to be negative 1.25 and positive 1.25. Multiply those 3 numbers together. Negative 2 times negative 1.25 times 1.25, 3.125. Which means our vertex is going to be at negative 0.75 and positive 3.125. So that negative 0.75 is negative 3/4, which is about here, and up to 1, 2, 3, just above 3. So there's your vertex. And our step number is -2, which means down 2, 6, and 10. So over 1, down, 1, 2, over 1, down 1, 2, over 1, down 1, 2, 3, 4, 5, 6, over 1, down 1, 2, 3, 4, 5, 6, and the 10 doesn't fit. Draw it in with a smooth curve. And there's your parabola. And then in vertex form, substitute into the general vertex form formula. It's going to be y equals -2, x minus -0.75 squared plus 3.125. You don't want to leave minus negative, it becomes plus. So there's our vertex form. So the success criteria, I can apply factoring to change a parabola from standard form to intercept form. That's what we did. And then we can sketch the graph of a parabola in intercept form by using the x-intercepts to calculate the vertex.